Hello and welcome to this lecture on experimental designs. After this lecture, students will be able to explain the experimental process, compare pre-test and post-test designs, as well as quasi-experimental designs, evaluate the internal and external validity of experiments, and identify different experimental designs. So what are experiments? Experiments are a study design in which the independent variable is manipulated and the dependent variable is measured. What this means is that rather than measuring the independent variable, we, the investigator or researcher, are actually going to purposefully change that independent variable and then measure the outcome. Experiments in this way then are always going to be explanatory and are not going to be descriptive, evaluative, or exploratory. We are always going to have a causal hypothesis with experiments. And the basic principle of a good experimental design is to do only one thing at a time. In essence, what this means is that the only thing that should change from one group to the next is our manipulation of the independent variable. Everything else should stay the same. And again, remember, this is because the goal of an experiment is to show a causal relationship. And if we remember back to earlier in the semester, a causal relationship must have an association between the independent and dependent variable. The independent variable needs to come before the dependent variable, and we need to eliminate the rival explanations or other extraneous variables. And this allows us to then test for statistical significance. Experiments tend to have high internal validity, and that is because true experimental designs control for all other variables to such a degree that any change we see in the dependent variable must be due to our manipulation of the independent variable. This manipulation is often called the stimulus, and this is the condition of the independent variable that we, the researcher, are introducing. And this is contrasted with a placebo, which is the simulated treatment of a control group that is designed to appear authentic or like the stimulus. And this means that we're going to have in any experimental design two groups, one control or placebo group and one treatment or experimental group. Because of this, and because we're going to randomly assign people to both those conditions, either the control or the treatment groups, we will have high internal validity because both groups should be identical except for my manipulation of the independent variable. In other words, experiments have high internal validity because they tend to use random assignment, where we assign people randomly to the control and treatment group, so that we have a constancy of conditions across those control groups. So everything about the experimental or treatment group is going to be identical to the control or placebo group. So the only difference between those two groups is going to be our manipulation of the independent variable, and then we will measure the dependent variable to see how our manipulation affected both groups. Following these steps and these requirements means that we will have ruled out extraneous variables and can therefore make a reasonable causal claim. While experiments do tend to have high internal validity, experiments also have lower external validity. And this is because a lot of experiments take place in a laboratory setting where it's very hard to make them appear realistic. In addition, experiments tend to have lower external reliability because there is no random sampling from a larger population. Most experiments are done on college students. And experiments have high internal validity, therefore, but then they have that lower external validity or ability to generalize from the experiment in the laboratory setting with mostly college students to a larger population. So let's talk about some different experimental designs. The first is a pre-test, post-test control group design. This is an experimental design with two or more randomly selected groups, at least one treatment and one control, in which the researcher controls or manipulates the independent variable and measures the dependent variable twice. We measure the dependent variable before our treatment and then after our treatment. So we're going to measure it before we've introduced our independent variable and then after we've introduced our independent variable. Hence the pre-test part of this pre-test, post-test design. This design does a number of things well. First off, it controls for the fact that sometimes there's maturation that occurs. People change over time as they're taking part in the study. It also controls for testing effects. It makes sure that both of our groups are equal to each other before we've introduced our independent variable. And it also controls for the fact that historical events happen and there might be something going on external to the experiment that might be affecting the participants. On the downside, pre-test and post-test designs are not always very possible and can be very expensive because we have to do both the pre-test and the post-test. But basically what this means is if I'm testing something, I can give you an exam, introduce my independent variable, and then give you that exam again. And if I'm giving that exam to both groups, I can see where each group starts, and this will allow me to ensure that both groups are equal before I've introduced my independent variable. Next, we have the post-test only control group design. This is an experimental design that gets rid of the pre-test. This is a much more common design because of its many benefits without the additional cost of including that pre-test. However, it does not control for extraneous variables as well as the pre-test post-test design does. And that's because without that pre-test, we can't always be sure that our two groups, our treatment and our control, are identical. With the pretest, we can check before we've introduced our independent variable and see if our groups are equivalent or the same. When we get rid of that pretest, we no longer have that check, and we are just assuming that our random assignment is going to take care of any differences between those two groups. And so without that pretest, it's difficult to determine whether any differences between our groups is due to our independent variable or some difference between those two groups. So it will increase our external validity because it's more realistic to have only one test after we introduce our variable, but we will take a little bit of a hit to our internal validity here. Finally, we have the Solomon four-group design, which, as it states in the name, has four groups. Basically, this design combines both the pre-test post-test design with the post-test only design, which one gives it the benefit of having that increased internal validity of the pre-test post-test, but also the increased external validity of the post-test only, with the downside of now we have to have four groups, which means this is going to be in a lot of ways twice as expensive. So what does this look like? Well, group 1 and 2 here represent the pre-test post-test design, while groups 3 and 4 represent the post-test only design. Together, groups 1, 2, 3, and 4 represent the Solomon four-group design. So with group 1 here, we have a pre-test, the treatment, and the post-test. Group 2 is the pre-test, the placebo, and the post-test. Group 3 is no pre-test, right? So now we're getting into that post-test only design, the treatment, and then the post-test. And with group 4, we have no pre-test, we have our placebo, and the post-test. So again, the pre-test post-test design allows us to ensure that both groups are identical before we introduce our independent variable, with the downside of it's more costly and takes more time, and we have less external validity, whereas group 3 and 4 represent here the post-test only design, which takes a hit to its internal validity while increasing its external validity. And when we combine them into the four-group design, we get the benefits of both, with the downside of the added time and cost that it takes to run four groups instead of just two. So far, we have discussed just true experimental designs. True experimental designs have the manipulation of the independent variable, as well as the control and treatment groups, where we randomly assign people to either be in that control or that treatment group. Quasi-experimental designs are missing one or more aspects of this true experiment. Usually this has to do with random assignment, meaning that we're not sure that our control and treatment groups are identical, and we've not randomly assigned people to those control and treatment groups. And this is frequently used when it's not practical or ethical to randomly assign people into control and treatment groups. An example of a quasi-experimental design is something called a field experiment. This is an experimental design that's done in the quote-unquote real world. It takes advantage of natural occurrences of control and treatment groups, and it sacrifices some of that internal validity that true experiments are known for an increase in external validity because we're doing something out in the real world. An example of this is a Bertrand and Mullainathan article that goes into racism and discrimination in hiring. Bertrand and Mullainathan created a bunch of fake resumes that were identical except for the manipulation of the names on the resumes. Some names were given ethnic or black sounding names, and other names were given more stereotypically white sounding names. These resumes, which again were largely identical, were sent out to a bunch of businesses, and they measured how many callbacks each resume got. This sort of experiment is taking place in the real world, and while they can't be sure that each manipulation of the independent variable is being perceived in the same way, they're sacrificing some of that internal validity for the increased external validity of having something done out in the real world. Another example of a field experiment is in the wake of the overturning of Roe versus Wade, where some states enacted very strict abortion bans while other states didn't. This meant that researchers could look at the effects of really strict abortion bans on two very similar states and see what sort of effects the abortion ban had on women in those states. Experiments typically have strong internal validity and weak external validity. They are typically very expensive and time-consuming to run, and we run the risk, as with a lot of sort of social research, of strong experimenter expectations, where the researchers accidentally or unknowingly communicate their desires to the experimental subject, similar to surveys where you have reactivity issues, or observational research or interviews where you're going to have peer pressure and social desirability coming into play. We have those same issues here with experiments. But the difference here with experiments is the focus on having that really strong internal validity, almost to the exclusion of everything else. Alright, that is it for this video. Thank you for watching.